Hi, everyone. So we're going to start chapter 3 now. And for 3.1, we're looking at increasing and decreasing functions. So like we see in the graph here, how do we know if a graph is increasing or decreasing? And that is relating to the first derivative. So the first derivative, now for right now, we're just going to look at continuous functions, right? So that continue on either side. It can be used to determine the intervals over where the function is increasing or decreasing. So if I want to know if a function is increasing or decreasing, I want to look at its derivative. So the function itself, the original function would be increasing when the derivative is greater than 0. So let's write that in here on the graph. So here, the function is increasing. It's telling us the function is increasing. So then in this portion, right, of the graph, then the first derivative here would be greater than 0, right? The original function would be decreasing. Also here it shows on the graph that we're decreasing when the first derivative is less than 0. So again, this section, I'll try to do my best here. This section of the graph, you can see that there would be where the first derivative is less than 0. And then if we're back to increasing, again, this portion of the graph is where the first derivative we know is greater than 0. Now, in terms of, let's say, this maximum point and this minimum point here, the original function has possible, there are some abnormalities, but we're not going to look at them now, but just know that it's not 100% a turning point. So it has possible turning points or local maximum and minimum when the derivative is exactly equal to 0. So when the derivative is exactly equal to 0, these are important values on the graph. So what is the value of x, right, that makes the derivative equal to 0? So that value of x, where the derivative equals 0, is what the critical numbers are our critical numbers that are telling us something important is happening on the graph. Probably it's a turning point. We just can't say 100%. Okay, so let's look at some examples. Actually, I'm just looking, let's write down, I'm sure you know, but we can just write down that these are turning points. Right, we know that that's a maximum, we know that that's a minimum, but now we're going to find it algebraically. And at this point here, at both of these points, so at this point here, again, the derivative is equal to 0. At this point here, the derivative is equal to 0, right? So when the function is at a maximum or minimum and the derivative is equal to 0 at this point or at this point, then a tangent line would have been drawn horizontally here or would be drawn horizontally here, right? And then the slope of a horizontal line is 0. So our first derivative is equal to 0. Okay. Let's look at an example. See if I can fit all this together here. For the function f of x equals x to the power 4 minus 2x squared minus 1, find the intervals, find the places where the original function is increasing and the sections where the original function is decreasing. So we already know that we need to get the first derivatives to help us with that, right? So let's just write that down. So the first derivatives will help us with this. So if we go back up to looking above here, we know that the function is increasing. The function increases when the derivative is greater than 0, right? So what we have to do is set the derivative to be greater than 0 as an inequality. We know that the function, so we need to find out the derivative first, right? We know that the function decreases when the derivative would be less than 0. And we have that inequality. So what we're going to do is find out what the derivative is and set that derivative to less than 0. And then I'll come back and explain this further. So let's get the derivative first. So f prime of x is equal to 4x cubed minus 4x, and that's it, then minus 0, right? 4x cubed minus 4x. And so if we set this function 4x cubed minus 4x to be greater than 0, and then we would need to solve for x, right, to figure out where are the values of x where I'm greater than 0, and then take the first derivative and set it to be less than 0, then we know that those are the parts where the function would be decreasing, right? But basically, if I'm looking at what's greater than 0 and what's less than 0, I could just find out where it exactly equals 0 and then look at what's happening all around those points, right? So if I find out the x values where the derivative is exactly equaling 0, and then I'll look at what's happening before that and after that. So that will help tell me whether it's increasing or decreasing. So what I want to do is basically just find out where it is equaling 0. So I'm going to take the derivative and set it equal to 0. And then what we're looking to do is solve for x, right? So how would I solve for x here? Usually we'd be factoring. So how can we factor? We check for a GCF first. Do we see one? We've got a common 4x. So if I took out 4x, I would be left with x squared. Take away 1. And am I done, or can I go any farther? If you notice, this is a perfect square, and this is a perfect square with a subtraction sign in between them. So this is a difference of squares. So I could go farther. 0 would be equal to 4x, and then the square root of x squared is x. Right? The square root of 1 is 1. And you have 1 as a negative and 1 as a positive sign. You could have that positive and that negative. So there's my factored form. The more I play with this, the worse it's getting. And sure, it erases everything except for that. All right, so sorry, x plus 1. Just trying to make it look somewhat legible for you guys. So what are my critical numbers? What are my x values then, where the derivative exactly equals 0? So my critical numbers are, this x value would just be 0. 4 times what gives me 0? X equals 0. Set x minus 1 equal to 0. Bring that negative 1 over to the other side, or the opposite of what's in the bracket. X equals 1. And then x equals negative 1, right? So now what I want to do is I want to test around these numbers because they are the turning points, probably. So these are the turning points. I have a turning point at x equals 0, x equals 1, and x equals negative 1. So the question is, before negative 1, was I increasing or decreasing up to that point? Because that would tell me if that's a maximum or minimum. And then what's happening after that point, and same. So what I want to do also is list them in numerical order. List all your critical numbers all the time in numerical order, from least to greatest. List these in numerical order from least to greatest. Okay? And what we're going to do in order to find out and take a look around these numbers is we're going to create a chart. I think I might need a little bit more room. Yeah, that's going to be a little tight, sorry. So I'm going to move this up. So just again, make sure you have all this down, take a screenshot or pause if you can, if you're not in class. And then we will continue on. So our values are x equals 0, x equals 1, and x equals negative 1. And also on our chart, we're going to be listing the factors of the derivative. So we're going to be listing that 4x is a factor, x minus 1 is a factor, and x plus 1 is a factor. And I'll show you how to list that in a chart. So you should be familiar with this from, if you remember, grade 12 functions. Okay, so first, actually, before I start my chart, I'm just going to do a number line, and I'll show you why here. So on my number line, again, remember how I said to list them in numerical order? So from the smallest value, was x of -1. So this is an x-axis here. And then I had a value of 0, x equaling 0, and then I had a value of 1, okay? And this is negative infinity, and this is positive infinity, going on forever, right? So just in terms of what are my intervals? So I have an interval from negative infinity to -1. I have an interval from 0 to -1. I have an interval from 0 to 1, and an interval from 1 all the way to infinity. So just to point out that I have 4 intervals that I'm working with. And those 4 intervals need to go in my chart. So if you have 4 intervals, you're basically creating 5 columns, okay? I think I could do it with straight lines here. I don't know. But that's going to take up more of my time doing that. Let's see. Just do it quickly. It doesn't have to be perfect. It doesn't have to be exactly a straight line that you're doing. But if you're really bad at drawing straight lines, then you might want to get a ruler out and do it, right? 1, 2, 3, 4. I could have one on the other side. I don't really need to close that off, so I can start with my rows. Let's see how many I would need. I'm going to need 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just have my titles at the top. Okay, hopefully I will do my best to write this out as neatly as I can, but just listen to what I'm saying as well. So these 4 yellow highlighted areas here are my 4 intervals, right? So leave a spot at the top left and write out your first interval. So my first interval is between negative infinity, comma, and -1. My second interval is between -1 and 0. My third interval is between 0 and 1. And then my fourth interval is between 1 and all the way to infinity. On this side here, remember I said I'm going to list the factors of the derivative. So I'm going to list my factors of, was it f prime of x? For the original equation, I think was f of x, right? And I list all my factors. So remember I said my one factor was 4x, my other factor was x minus 1, and my other factor was x plus 1. And then this is going to be the overall sign. Change this to red. Just want to make sure I fit it in here. This is going to be the overall sign of the derivative. Overall sign of f prime of x. And then this is going to be our final answer of, is the function increasing or decreasing for the original function, for f of x. And I can just extend that down a little bit. So what am I talking about? How do we do this here? So it's up to me now, it's up to you guys to pick any number you want between negative infinity and -1. But you cannot pick the numbers that are actually up here. So you cannot pick -1, 0, 1. Basically, that's it, right? You cannot pick the numbers that are there because it's up to those numbers, but not including them. So if I wanted to choose something like, -2, -10, it doesn't matter. So even if, more than likely you're going to pick -2. Let's say we were to pick -4, just to pick something not so obvious at first. And I'm going to plug this -4 into these x values. And all I'm worried about in the columns here is saying whether my ending result is going to be positive or negative. So for example, 4 times x, and x is now -4. 4 times -4 is -16. All I really care about is that it's negative. If I were to sub in -4 in for x, I'd have -4 minus 1 is -5. All I care about is that it's negative, sorry. -4 plus 1 is -3, it's still negative. And then here, the overall sign for the derivative is, if we were to go and look at the equation, all of my factors are being multiplied together, right? The answer was 4x times this times this. So if I multiply all of these signs together, a negative multiplied by a negative multiplied by a negative, negative and a negative is a positive, positive and negative is resulting in a negative overall. That negative there is telling us that it's decreasing, that the function in this interval is decreasing. So let's do the rest of the chart. So a number between -1 and 0, but it can't be -1 or 0. So more than likely we'd be picking -1/2, right? So 4 times 1/2, so cutting 4 in half and making it negative would be -2 would be a negative. A -1/2 and then subtracting another 1 would be negative. A -1/2 but adding 1 would be positive. So now we have to be careful when we multiply those three together. A negative multiplied by a negative gives me a positive. That positive multiplied by the third positive, this answer is going to be a positive answer. So my interval is increasing over this interval. Okay, a number between 0 and 1, obviously I'm probably going to pick that positive 1/2 this time. So again, that would be 2, that would end up being a positive number. If I had a half and I subtracted 1, I would be negative. A half plus, positive. So now I have a positive multiplied by a negative. Negative, negative and positive, negative. You don't have to write these three down, but it might help to visually see them, right? To not mess up on this sign. So I would slow down here. So then my original function is decreasing here. If my derivative is negative, right, less than 0, in the bullets at the very top of page 1, then that tells us that it's decreasing. And again, a number between 1 and infinity, let's say we did pick the obvious, maybe 2 there. 4 times 2 is 8, positive. 2 minus 1, I'm still positive. 2 plus 1, I'm positive. This one's easy because a positive times a positive times a positive is going to be a positive, and the function is increasing. I could write the whole word, it's just that I'm not able to fit it. That's my only problem there. So make sure to place these numbers in numerical order. We said that on the bottom of the first page. And now my conclusion. Find the intervals where it increases and decreases. So therefore, the function is increasing when I'll show you two different ways to write it out, right? So the function is increasing when I'm in this interval between -1 and 0, and this interval between 1 and infinity, right? So what I could say is the function is increasing when x belongs to the interval between -1 and 0, and x belongs to the interval between 1 and infinity. So that's one way to write it. Or you could just say between 1 and 0, right? If x was between -1 and 0, you could write it out that way, not including these numbers, right? So between -1 and 0, and then basically this is just greater than 1, and x being greater than 1. So you can write it out either way. It doesn't matter whatever preference you have. And then f of x, the original function, is decreasing when, so again, it's decreasing when I'm between -infinity all the way up to -1, not including, and it's decreasing between 0 and 1, not including those numbers. So the function is decreasing when, again, however you want to write it out, x is less than -1, and x is, sorry, I just need a little bit more room here, between 0 and 1. So x is between 0 and 1, not including those values. So don't put the equal to with it. Okay? So one more portion of this lesson. Let's look at this section number 2. Now this is the reverse of a couple videos ago Then I gave you the original graph and I asked you to graph the velocity and acceleration graphs. Here I'm giving you the derivative graph. So the derivative would be the velocity curve, right? So just to write that out, and I want you to go backwards, if you will, and write out what the original graph would look like. So this is our velocity curve. This looks what? Remember in the previous videos, we had one that looked cubic, one that looked quadratic, and one that looked linear. So this one looks quadratic. So it has its highest degree is 2 if it's quadratic. If that's the derivative, and I'm going back to my original would be 1 degree higher than that. So my original function would be cubic, just so I have an idea then what it would look like, which obviously is degree of 3. So let's start. Obviously, we have to point out something on this graph. So this is the derivative graph. So the derivative of x here is equal to 0 here, where the derivative, where the y value is 0 here. Where f of x is equal to 0 are going to be turning points for the original, right? Because we just looked at where the derivative is exactly equal to 0, where the derivative, the y value is exactly equal to 0, is either a max or a min. So for right now, I don't know if it's a max or a min, but I know just in my head, kind of graphing this out, one of them is going to be a maximum and one of them is going to be a minimum. So let's take a look at how do we figure out whether we're starting down low and going up to a max and coming down, or how do we know if we're starting from above and coming down to a minimum point and then coming back up? So that's where the rest of the graph is going to give us that information. So there's a couple different ways that you can look at it. Since the derivative is ending down, right, below 0 on the x-axis, then the original graph is going to need to end in a down position as well. That's one way that you can look at it. Or if you look at the starting value here, I'm below the x-axis. So here's my x-axis, right? I'm below the x-axis to start. So my derivative here, to write out, my derivative is less than 0. So if my derivative is less than 0, I know that the graph has to be decreasing to start. So I'm starting out up higher and decreasing. And then all of these values here is where the derivative is above the x-axis. So all of this value here is where the derivative is greater than 0. So for this whole section, the derivative to be greater than 0, that whole section is increasing. So if I was to, I'm just looking, I think I'll draw it out for you and then we'll just kind of add those little tidbits to the graph with words to help you when you're looking back to see how we got there. So it doesn't, there's no numbers here. It doesn't matter where, you're just picking a value on that dotted line. That would be a minimum point. And then we know that this section is increasing. So I'm increasing to a maximum point, right? And then again, I'm below the x-axis. I'm starting at an ending down. So I need to end down in the original as well. And then I come back down. So again, this section of the graph from the derivative, this section here is where my derivative started out less than 0. So because it was less than 0, I had to be decreasing. This portion of the graph here is where my derivative is greater than 0. So this portion of the graph here, this portion of the graph, I'm increasing, right? I have positive first derivatives, positive meaning that x is greater than 0. And then for this section of the graph, again, my derivative is less than 0. My derivative is less than 0. So here in this section here, I was decreasing. Right? In this section, same thing. I'm decreasing. And then in this section, I'm increasing, right? And at these turning points here, the derivative is equal to 0. At this turning point here, the derivative is equal to 0. So we know that this is a maximum point and this is a minimum turning point. Just looking at what else we can add to the graph. Hopefully that's enough for you. I'm also just seeing anything else to add to the graph is kind of going into answering B. So let's look ahead at B then. State the intervals, right? Looking at the graphs of increase and decrease for the original function. So what are the intervals where it's increasing? Where are the intervals where it's decreasing? So it's decreasing. Now, this is where I said we have to add one more thing to the graph. We don't have any numbers on the graph, right? So how can I kind of say the intervals are decreasing between here and here? How do I have to call that something, right? The interval is increasing between here and here, the x values, and the x values are decreasing after this value. So let's just call this, you can call it anything you want, any variable, but let's just call it A, and let's call this point here point B. So state the intervals of increase and decrease for the original function. So the original function f of x is increasing. Let's start with when. It's increasing. Let's go up and take a look. The original function is only increasing between A and B, but at least now we can say starting at A and ending at B, right? Not including those values, right? It's increasing right afterwards and all the way up to, but not including. So between, x is between A and B, it's increasing. And f of x is decreasing when it's decreasing when it's less than x, right? X is a value when x is less than A and when x is greater than B. So when x is less than A and when x is greater than B, if that makes sense. So again, to answer B, we're going to use our original graph. So just to write there, use original graph. And if the original graph is going downwards, then we know that it's decreasing. And if the original graph is moving upwards in an upward direction, then we know that it is increasing. The function is increasing. Okay.